Okay, so you are Shubham Tripathi, right?
Yes, sir.
So hi Shubham, Rahul this side,
Hi.
and I can see that you have applied for data scientist role in our company. Am I right?
Yes, sir.
Okay, so Shubham, please start your interview. Let's start your interview. Please brief me about yourself.
So my name is Shubham Tripathi, and I have graduated in civil engineering from Guru Gobind Singh Indraprastha University. After that, sir, I came across data science and I started to explore it. So I spent a few months, learning about data science and machine learning, deep learning, neural networks, and your NLP, GANs, and all. And later on, I started solving Kaggle competitions. And now I personally feel that I am, capable enough to score a good job or get a good job in machine learning and deep learning. And
Okay,
I have,
so
apart from that, I have interest in sports and all.
okay, so you graduated in civil engineering, yet you are pursuing with data science.
Yes, sir.
So how did your interest get shift from civil engineering to data science?
Actually, sir, one of my friend was here, like in this field, and I was doing some work in civil engineering, but he asked me to, explore it a bit. And I saw a few of his projects, so I was fascinated by that. So I thought that I have to learn this, and after that, I started exploring. I started learning a bit, and that's how I just shifted. My focus shifted in this field.
Okay, nice, very good. So, okay, Shubham, let's start with your interview. Okay, let's really get start from here. And okay, so you have told me that you are experienced in machine learning and deep learning. Am I correct?
Yes, sir.
Okay, so I am more of interested in deep learning. So let's start with it. Okay, so my first question is very a basic one. What is deep learning?
Sir, deep learning is actually a part of machine learning and artificial intelligence. What we try to do is mimic our brain. So we have our neurons, and they, like, for example, I have this layer as an input, and like I have a few other layers. These are hidden layers, and I get an input, and then these are transferred to other hidden layers, and that's how it goes on. So what we are trying to do here is we are trying to mimic our human brain, and that's how
So,
the like
I
entire
understand.
idea. Sorry, sir.
I understand, but this is like more of a technical definition. Okay,
Yes, sir.
like you are explaining it to me, and I already know about deep learning, so I am able to understand it. But if you are now asked to tell deep learning to a layman in layman language, like to a student who is you can say who has never touched this topic, so how will you explain it to him?
Sir, in that case, sir, like what happens here is in deep learning, we are exactly doing what our human brain does. Like what happens is, for example, if I see a hot object, right? So I instantly know that I don't have to touch it because my hands will get burned over here. So how did we do this? We learned it by experience. So this is what we actually do when we train a model in deep learning. We are training it by actually teaching it how to do in let's say uh, like how we did as humans. So what happens is as soon as I see a hot object, I see an impulse, and there are neurons in our hand. So what they do is they transfer it to our brain that this is a hot object, and then our brain tells us that don't touch it, it's hot. And how did this happen? Like we learned it because somewhere down the maybe our parents told us, or we
Like
touch.
you are
Yes, sir.
saying from past experience.
Yes, sir, exactly. From past experience,
But
we know that we
that
don't
is
have to
not
do it.
that is not deep learning, that is reinforcement learning, like where you are exploring and getting yourself. I'm asking you about deep learning. Like you said, you were correct about the initial one, like that it was developed when we are trying to mimic the human brain. So tell me, why do we require to mimic human brain? Okay, we were studying machine learning earlier. Okay, but why did we find a need to like mimic human brain?
So actually, what happens is like in our machine learning, the data set is actually a little small. But when we go to large data sets, then we actually need a very complex network where we can, like for example, I have an image, and I have to like see I have an image of a dog. So I have to take some characteristics out of it. Let's say that it has an ear, or it has nose, or it any feature of a dog. So this is not possible in machine learning, because then how will we you know how will we extract those features? Because we don't have a complex network. So what happens is that we have to extract features, and that is where the deep learning comes into play. Because what it does is it extracts the features in a picture in this case, but in general when we are trying to prepare a model, it extracts those features and then it transfers these inputs in the form of neurons. And that's how like we try to mimic the human brain. Like when we see a dog, then instantly there are certain features of it that our brain extracts, and we know how it's working, so or what is it. So that is exactly how we do here, that we extract these features and send it in the form of impulses as input, and then there is some processing that's done, whatever model we try to create, and in the end we prepare an output.
Okay. So as far as I can see, there are two major reasons for deep learning. One is to deal with, to deal with large data set. Okay. The second one is to deal with complex data set.
Yes, sir.
Am I
Exactly.
right?
Right. Yes, sir.
Okay, okay, Shubham. Good. That was a very good introduction that you gave me. Okay, now while you were giving me the answer of previous question, you mentioned something about input layer, hidden layer,
Yes, sir.
like that. Okay.
Yes, sir.
So what are can you please tell me what constitute of an input layer and hidden layer?
So actually, let's say if I have something like this and I have an input. So this in the first layer where we take the input, or like I was giving an example of a picture. So the first, as soon as we pass the picture into our model, that layer, the first layer that our input or whatever we are trying to process passes through, that is the first layer, that is the input layer. Then there are a few layers where actual processing is done. Like let's say I have to extract features of a dog. So what I will do, and actually I have to I have prepared a model where I have trained my model for predicting a lot of images of dog, and I'll show it one image and it will predict that whether it's a dog or not. So here I pass that image of a dog, and then there is certain feature extraction. Like say there is some layer which is dealing with the ears it has, or the
Okay,
feature
okay.
of its ear,
Some
or
computation, some
uh,
computation on it, and then you get the output.
yes,
Okay,
sir. And
but
these are hidden layers, and in the end, whatever whether it's uh, a dog or not, that layer is the output layer. Yes, sir.
okay, okay. But my question is, what is this as a whole called?
Sir, this is an artificial neural network.
Yes, this is a neural network, basically a
Yes,
neural network.
yes,
Okay.
sir.
So now I want you to define what is okay, you have defined what are the type of neural networks that we generally use.
Sir, we have the basic one, like artificial neural network, so consists of all these. Otherwise, we have CNN, convolution neural network. We have RNN, recurring neural network. And sir, I can remember only these two right now.
And the general one, which is ANN.
Yes, sir. Like I told earlier on, like the artificial neural network is the basic one where we started all this.
Okay, but okay, okay, good. Okay, okay. Now, okay. So you give a very good explanation about neural network. Now, like what is the in a neural network? Let's say this is my hidden layer. Let's assume this is my hidden layer. Okay.
Okay, sir.
So what is this in a hidden layer? What is this?
So
there is an actual term which we give this, which we give these to these objects that take.
So this I think is a perceptron. So a neuron will come over here, and there will be certain like processing done, and another neuron which fires the output from this perceptron. And there are certain, like if I have one, then this is one perceptron, single perceptron, and if there are two, three, then I think this is a multi-layer perceptron.
Okay, so okay, this actually, this whole is a perceptron. Okay, you are correct. Now, what is the difference between this? Okay, so what does this perceptron do? Let's just a minute. I'll clear this all drawing. Okay, okay. Now, please tell me what does actually a perceptron do?
Sir, I get, like, let's say if I have an X input and I pass it through a perceptron, so I will like it does some processing and it passes an output that it multiplies the weight wx plus b. So what happens is there would be some weight associated with this neuron. It will multiply that and with a bias, and then it will send it out as an output. And
Okay.
otherwise, so we have activation functions and all here. So that is also a part of processing. But in general, if there is no activation function, then if there is an input x, it will go through some processing and there will be an output wx plus b.
Okay. So, okay. So what is this W here?
So this is the weight.
So what is a weight?
So like, for example, if I have a very dense neural network, and let's say I have 4 perceptrons here. So what happens is that there is one neuron coming from here and there is one neuron coming from here. But it is not always possible that this neuron and this neuron carry the same amount of weight.
Okay, Shubham, first that is not a neuron. Okay, that is input. Okay.
Okay, sir.
Neuron are the circle-like structure that we are seeing here. These are inputs. Okay, continue, please.
Yes, sir. So if like, let's say there is an input here and there is an input here. So what happens is that it is not always possible, or in generally it's not always true that both of these will carry the same amount of importance. Actually, we can say this in the same ways in our actual brain structure also. It's all the neurons that we have, they don't possess the same amount of importance. Like we say sensory senses. Like, so if I have to if I touch something hot, so my vision, the neurons in my eyes, they don't at that particular time they won't carry as much importance as my touch or the neurons in my finger. So the weights actually represent the importance of that particular input in that model. Like if I have a weight of, let's say, 5, and if I have a weight w1 and w2 of 7, so that means that the input with a weight of 7 is a little more important as compared to with an input with a weight of 5.
Okay, so you are saying that weights are generally related to like the how much importance that input is carrying.
Yes, sir.
Okay, okay. And what is this B that I see here?
So bias is like, this actually represents that sometimes it might like in machine learning we talk about overfitting. So in that case, what happens is like if I have some points here, and if it is trying to overfit, so it is getting biased to a certain type of output. So this actually represents that how much biased is it, that particular input is, like the processing is to that particular input. So bias actually tries to create some equality in my data, that it should not be biased, or it should not favor a particular type of output. So this actually represents that we need to randomize our data.
Okay, so this is creating importance and this is destroying importance. So why are we doing this? You said that this is creating some randomness.
Yes, sir.
But we know that W is assigned for weights, like how much importance a particular input is carrying. Am I correct?
Yes, sir.
So W is creating importance, but B is destroying it. So why are we including them at all in a neural network?
So this is because like we need to create, first of all, W is because we want, to with respect to our output, we want to create a certain type of importance. Like, for example, if I have a dog and we know that it has certain types of ears, right? But like it has certain types of ears, and that ear, the fur it is carrying in that ear, or any important feature of a dog, we want that the input carrying that particular feature should be important while predicting the output. But let's say it has 4 legs, that is not as important. Or if I say that it is biased, that anything that my model is getting biased towards 4, if it has 4 legs, my model will say that it is a dog. So it will also say that if I show a picture of a horse, it will also say that it's a dog, which is not true. So but we include bias, that it should not be biased to certain types of outputs, that which are not as important. But weight is for something which will hamper my actual output which I require.
Okay, So, so what is overfitting in your what is overfitting in your dictionary? What does overfit means?
So overfitting in my dictionary means like if I have like we talked about fitting my data to a certain line. We have all studied this in earlier classes. So what we do is we don't try to pass my line through every point. But because in that case, what happens is that if I produce certain type of input which is here, so it is not going to predict it correctly. So overfitting in my sense is that it will perform very well when I train my data. Training accuracy might be 100%, but when we test it, its accuracy will be very less because it is not trained to that particular type of data, right? It actually creates bias, in my opinion.
Bias? No, it does not
Like,
actually create
sir,
bias.
actually, yes, sir.
But let's say your data, your model is performing well on both testing data and training data.
Yes, sir.
Okay, so again, so if it is creating, if it is performing well on training and testing data, does that mean it is overfitting?
No, sir, I don't think it's overfitting in that case.
So, but let's say that by not including this bias at all, my data is performing good on both training and testing data. So, do you think we will need this bias again?
So actually, it depends upon case to case because there might be a situation where bias does not carry that much value, or it's not as significant. But there could also be a possibility that because it's not always true that we carry the entire thing. There is a possibility that this is the negative. Sorry, sir.
Okay, I understand. I understand, Shiva. I understand. Let's just okay. Good. Now, okay. So now, okay. So let's go back to this normal thing that we had. Okay. This is receiving an input, and let's say Y is our output here. Okay. You said that certain action is being performed here. So what are these actions? What is this action called?
So it has an active, like there is an activation function over here. So what it does is, firstly, it tries to bring in certain amount of non-linearity in my data, because it is not always possible that all my inputs, and in fact in most of the cases all my inputs do not lead to a linear output. Like wx plus b is actually a type of straight line. So it is not always true, and in fact most of the cases it will not be true that if I produce if I pass an input x, it is going to produce a linear output. So firstly, we have an activation function over here so that it processes this to bring in certain amount of non-linearity. And secondly, it tries to normalize my data also, because we don't want that I have certain inputs and it's produced, outputs are more like 10,000 and some outputs are more like 3 and 4. So when I try to process the entire thing, it is going to produce absurd results. So that is why we need to put everything into a certain bracket so that everything is normalized, like everything is in a certain range, so that processing is I would say processing would produce good results. So first thing is producing non-linearity, and second thing is normalization.
Okay. So give me a few example of these activation functions.
So we have a sigmoid function, ReLU function, and we have leaky ReLU activation functions. After that, we have softmax is also an activation function. We have Swiss activation functions, and so there are a lot of activation functions for that matter.
Okay. So why do we have different type of activation function?
So actually, it's not, see, for example, my data, if I have to predict some sort of probability, that what is the probability that certain image is a cat. So in that case, I would need a sigmoid because its ranges from 0 to 1. So anything where my answer is within a certain range of 0 to 1, their sigmoid will perform well. But let's say if I have something related to 0 to infinity, so in that case, I would need a ReLU function because that will go from 0 to infinity. So actually it depends upon what type of data I have and what type of processing I need to do in it. And also what type of output I need. So all these factors, because see, if I have to do classification, then we have our softmax and Swiss functions are very good for image classifications. So it totally depends on what type of data we have.
Okay, so you are saying that if I want to do classification, I cannot use ReLU function.
So I wouldn't say that you can't use, but it will not be as accurate as something like softmax and Swiss.
But I have achieved a pretty good accuracy with value function and not with sigmoid function.
Sir,
Actually,
sir,
in practical demonstration, I can say that sigmoid will perform less than a value function in classification.
yes, sir, right.
Okay. Okay. So it's not that. Okay. So tell me the formula of sigmoid function.
The sigmoid function, so sigmoid function will be 1 upon 1 plus e to the power minus x.
Okay. And what is the output of sigmoid function?
So it will be between 0 to 1. And the mean value, actually its graph is something like this here. So it cuts the y-axis at 0.5. So mean values would be around 0.5.
Okay. Okay. Good. 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 Okay. Now let's move ahead. Okay. So in deep learning or in neural network, there is a term called batch normalization. Have you heard
Yes,
of it?
yes, sir.
Okay. So please tell me what is the use of batch normalization and why is it necessary?
So actually batch normalization is, normalizing the entire data to a specific range, because firstly we need the output to a specific range, and also the processing, like I said, activation functions also does a little bit similar like on a very small scale, but while processing. So batch normalization is actually uh, you know shrinking down, or actually putting the values in within a specific range so that processing is easier and we get our desired output.
Okay, but okay, I have a little doubt here. You said that batch normalization normalizes the function, normalizes the value.
Yes,
Okay, activation function also normalizes this, and we know that activation function is applied on every neuron in a
yes,
neural network.
yes, sir.
Okay, so you can say that normalization is taking place at every neuron. Okay,
Yes,
so
sir.
it will bound it to a specific range only.
Yes, sir.
What is the use of this batch normalization? Because normalization is taking place here as well. What is
Yes,
the
sir.
need of it? What is the need of batch normalization?
So actually what happens is, like for example, I normalize my data and I get something like, let's say one time I normalized it and I have something like 0.5 and I have 0.75, and I have to predict some probability, and later on I have to apply some function and it's just getting added. So I get a value of 1.25, but probability cannot be 1.25. So that's why I need a batch normalization also, because after processing the
So,
entire thing should also be. Yes, sir.
what this is output of a single, you can say, let's say you have two images here, image one, image two. This is output of image one and this is output of image two.
Yes, sir.
Okay. You are calculating probability.
Yes, sir. So
But
actually, yes, sir.
also isn't this probability the output that you will receive? Final output of a new in a
Actually,
neural network.
so this is not actually the final output. This is, let's say if this is an image, actually it's for the same image we extracted some features. So the probability of, like, I would say that it's a, uh, let's say it's a horse. So it will have 2 ears, there is a probability, and it has, let's say, 4 legs, this is a probability. So the both of these, this was just an example, like to see that two features, if they are added together, they might produce a value which is larger than what we require. So I was just trying to signify that, like, this is not exactly the probability. This is, what is happening within, before we are predicting the exact probability. So what batch normalization does is,
Okay.
us every time that we normalize the value in an activation function, we, after that, the output is going to another neuron, and there is some processing which will be done over there. So if we are processing two different types of values, it is also possible that it exceeds our desired output. So that is the reason we, do batch normalization also, so that single neuron, it's okay. But when we combine it, the entire thing should also be within that specific range.
Okay, so if I know that this will give me a probability, this will give me a probability, and finally I need a probability, can't I use an activation function here of sigmoid? Because I know that no matter what the value will be, I will always get it between 0 and 1.
So you can, so I don't think that would be the right like approach, because see, if I apply another, neuron over here in another processing function over here.
Forget it, forget it, forget it. Let's say my probability for the final layer comes out to be this.
Yes, sir.
Okay. I have 4 neurons here, right here. Okay. This is my final output layer. Okay. I will receive inputs here. Okay. This is my input final perceptron, which will give me an output. If I apply sigmoid function right here, will the probability go over 1 in any case?
No, sir, it won't go over 1, but sir, I personally feel that it will increase the complexity of my model, because I am actually, I can do this all in
How?
one. Yes, sir.
I, instead of just applying it to some batches, all I have to do is apply it. Is I have to just change one letter, one, you can say one alphabet here. Instead of rel u, I just have to write sigmoid in the final layer. So which one is easy, doing this or doing this?
So I would say batch normalization is easier, because see, what we are doing is, instead of doing all that, we know that the specific
Just a
region.
minute, just a minute. I hope you have worked on. I know you have worked on several projects. Okay, you create a CNN network. Okay, so in the final layer, when you give out the output layer, you just add the dense layer right here.
Yes, sir.
You specify the number of output you want,
Yes, sir.
and in the activation function, you just give it an activation function. That's it. This makes your output layer. Am I correct?
Yes, sir.
So all I need to do is I need to change this. Am I right?
Yes, sir.
But if I have to do batch normalization, then I have to first split the data, then I have to normalize it, and then I have to reshuffle it back again to process it. So which one is easier, this or this?
So easier is that, but so I personally feel that batch normalization is like, it's a type of algorithm that we go through, but in the end, if I'm again applying an activation function, so actually activation functions are more like that. See, if I apply an activation function over here, so it will process on wx plus b. So first, whatever output I have, it will be, it will be multiplied to a certain weight. So in before passing it to the output, first we have to assign the particular, weight of that neuron. And even if I assign it to 1, there is the bias term. You can take it 0, but then it will be a very complex thing, because we are actually manipulating the entire data over there.
अरे भैया मैं तो इतना पूछ रहा हूँ तुमसे कि वेट और बायसेस तो तुम देते हो, ये तो न्यूरल नेटवर्क खुद कैलकुलेट करता है, तुम इनिशियली नो रैंडम नंबर देते हो, हाँ या ना?
यस सर।
तो जब सिंपली यहाँ पे एक्टिवेशन फंक्शन लगा के सब कुछ ठीक हो रहा है, तो तुम इतना बड़ा प्रोसेस क्यों कर रहे हो? चलो ठीक है, छोड़ो, let's leave it. Okay, no issue. You explained batch normalization pretty well. Okay, now let's move on. Okay, so do you know about a term called backtracking? It's a very famous term in neural networks.
Yes, sir.
Okay, so what is backtracking?
So in the end, like when we get our output, we need to, optimize our weights so that we can increase the accuracy. So that's when we go back in our neural network and we try to optimize our network by, processing the weights again. So actually changing the weights and processing it for a better output. That's backtracking.
Okay, good. And what is an epoch?
The epoch is like when we are actually, what happens is we send our data in the form of batches. So it is sent one batch and then another batch, and after the entire thing is done, we go back and try to optimize our data. So one time when we process the entire data, like sending it in batches, processing it, then back tracking and optimizing our entire network, that's one epoch. Like processing the data one time is entirely is one epoch.
Backtracking optimizes your data?
No, like optimizes the weights.
Good. Continue.
So that's one epoch actually. So the entire thing, training our model,
okay,
and then optimizing
thing.
Yes, sir.
Okay, good. Okay. So now let's talk about some of your projects. Okay, tell me some projects that you have built.
So I have used CNN and worked on some OpenCV projects, and apart from that, sir, I have worked on a few NLP projects. And so NLP project was sentimental.
Tell me, okay.
Sorry, sir.
Okay, so if I have to say you what was the best project that you have done, what would it be?
So I have worked on. So I had made a mask detection model that used to detect whether a person is wearing a mask or not. And apart from that, sir, I had worked on a little CNN architecture to prepare. Like, sir, we play these games, hill climb and all. So what we can do is we can create a bar and use our hands to like play. Actually make it more interesting. Like use facial features. I use MediaPipe and OpenCV libraries to prepare that.
That's basically under OpenCV. So you have worked with OpenCV.
Yes, sir.
Okay.
Yes, sir.
So when while you are making mask detection, that mask detection feature,
Yes.
so did you use any neural networks in it?
So I use CNN.
Okay. So how complex was that neural network?
So it wasn't like very complex. I just used I used 5 layers at max. I personally, if, whatever I can recall, it was like the input was like 256 filters, and then it moved on. Like there were 5 layers, like 2 convolution, 1 max pooling, and then I had 0.25% dropout, and like this there were 5, and eventually the dense one.
Okay. So how much accuracy you were achieving while using this?
So 84%.
84%. Okay. So what would happen if I increase these 5 layers to 50 layers? Would there be any change in in the accuracy?
So there might be a change in accuracy. Actually, what happens is when the epochs are running, the data is getting processed. So there is a very high possibility that the accuracy would be increased. But then after a certain time, as the epochs increase and these layers increase, the accuracy starts to decrease. So that is why there is a possibility. There is a high possibility that it would increase, but it might also decrease.
Okay, okay. So this thing that you have reminded me of very good question. Okay, so are you familiar with the term gradient?
Yes, sir.
So what is a gradient?
So gradient in actually when we are backtracking and optimizing our networks, we actually see in general, if I talk about general maths, gradient is a slope. So what we do is like d theta upon dx is actually a gradient, where what we are trying to do is we are trying to calculate the slope.
D theta? What is d theta?
So actually, if I have, let's say, if I have this line and I have to find a slope, so d theta upon dx is the slope, and otherwise it's change in theta with change in x.
Okay, okay, okay. So gradient is basically you are saying gradient is slope.
Yes, sir.
Okay. So okay, so there are two things that happen while we are using CNN. Okay. There is something known as vanishing gradient.
Yes, sir.
Okay. And there is something called explosion gradient. Okay.
Yes,
Exploding gradient.
yes,
So
sir.
what is the difference between these two?
So when we are actually optimizing, what happens is that while gradient descent, like what is like, let's say I have something like this, if I have something hill climb, so this is basically how my gradient descent works, that it's going down, right? So what my vanishing gradient is like, we are, see, when we are backtracking and we are optimizing our weights, there could be a possibility we optimize it so much, like let's say if I go back, so it optimizes a bit. So after certain optimizations, there is a possibility that it reduces to zero altogether. So that is a problem of vanishing gradient. That gradient is,
It doesn't reduce to zero. Actually, it doesn't reduces to zero. Okay, so let's clear the screen. Okay, can you recall the formula for optimizing the weights which you used in neural network?
so it was so actually I don't remember with exact terms, but like it was more like, let's say I have
Okay, I'll write it for you. Okay, so it was W old minus d theta by dw. Okay,
yes, sir.
so this was the term. Okay,
Yes,
so okay, so tell me what happens in vanishing gradient. What does your slope become? What does the value of your slope becomes?
so actually it reduces to a very insignificant value, like these two values will almost be equal when
So this will reduce to, let's say, zero. This will reduce to zero.
yes, like a negligible value.
So this means that my new weight will be equal to my old weight.
Yes, sir. Like there will
Okay,
be
so
no
there is no
effect
further.
sorry, sir.
There is no effect of optimizing here. So the weights does not reduces to zero, but they start becoming constant.
Constant, yes, sir.
Okay. Okay, so this is vanishing gradient without exploding gradient.
So exploding gradient is actually increases so much that it sort of explodes, uh, like it is changing so much that the entire thing is changing. Like there was no effect of my training, and entire weights are changing so much that there is a lot of difference between, there is a huge difference between these two values. So it's more, yes, sir.
It's like become jumping around. Okay, it's like
Yes, sir.
it becomes
Exactly.
random.
Yes, sir.
Good, good, very good, very good. Okay, so that's it, Shom. That's it from my side. Do you have any doubt regarding the interview process?
Sir, could you just tell me like how was my interview, and any tips for future interviews?
It was very good. It was very good. Okay, it was very good interview. I thoroughly liked it. Okay, it was fun talking to you. Okay, so let's close this interview here. Okay, you will get a call from HR if you are further selected. If you are selected for further rounds. Okay.
Yes, sir.
Till then, just keep your finger crossed and just keep praying. Okay.
Yes,
And
sir.
it was nice talking to you, Shubham.
Yes,
Okay.
sir. Yes, sir.
You
Thank
can
you,
leave
sir.
now.
Thank you,
You
sir.
can leave. Thank you, Shubham. Thank you very much.
Thank you, sir.